Today's video is a special lesson. So let's talk about trigonometry. But first, subscribe to the channel, leave a comment, and hit the like button if you enjoy the video. The word trigonometry comes from the Greek trigonom, which means triangle, and metron, which means measure. In other words, trigonometry is the study of the relationships between the sides and angles of a triangle. It was created to solve problems in astronomy and navigation, but today it's used in engineering, physics, architecture, computer graphics, and many other applications. An angle is formed by two lines or segments that meet at a point. Basic trigonometry starts with right triangles, which have a 90-degree angle. The hypotenuse is the side opposite the 90-degree angle. The adjacent leg is the side that touches the angle, and the opposite leg is the side in front of the angle we are analyzing. The main trigonometric ratios are the sine of an angle, which is the opposite leg over the hypotenuse, the cosine of an angle, which is the adjacent leg over the hypotenuse, and the tangent of the angle, which is the opposite leg over the adjacent leg. From this, we can see that the opposite leg is equal to the hypotenuse, which is dividing here, goes to the other side as multiplication. It's equal to the sine of the angle times the hypotenuse. Same thing here. The adjacent leg is equal to the cosine of an angle times the hypotenuse. Because here it's dividing, so when it goes to the other side, it multiplies. So it goes over here to multiply over here. That's the reason. Now let's move on to the important trigonometric identities, which are the sine of an angle squared plus the cosine of an angle squared equals 1. The other important concept is that the tangent of an angle is precisely equal to the sine of that angle divided over the cosine of the same angle. Let's do an exercise. If the sine of an angle is equal to 0.6, what is the cosine? Applying the formula here, it becomes 0.6 squared plus cosine squared equals 1. 0.6 squared is equal to 0.36 plus cosine squared, which equals 1. So cosine squared equals 1, and here it's plus, but when it goes to the other side it becomes minus 0.36. So the cosine squared of the angle is equal to 0.64. Since here the exponent goes to the other side as a root, the cosine of the angle is equal to the square root of 0.64. So the cosine of the angle is equal to plus or minus 0.8. And why plus or minus? Because the square of a number is always positive. Now let's move on to another concept. Angles are similar when both have 90-degree angles and the other angles are also equal, like here. 30-degree angles and, in this case here, what's left is 60 degrees because the total is 180. So they are similar angles. The sine, cosine, and tangent are the same. If in the first triangle the hypotenuse is 10, and in the second, which is twice as big, the hypotenuse will be 20. And the same goes for the legs. Now let's find the adjacent leg, which is equal to the hypotenuse, which is 10, times the cosine of the angle, which is the cosine of 30, which is equal to 10 times. Cosine of 30 is 0.866. That's in the trigonometric table. So the adjacent leg is equal. You just move. Multiplying by 10. You just move the decimal one place over. It comes here, so it becomes 8.66. The opposite leg is equal to the hypotenuse times the sine of 30, which is 0.5. So the opposite leg is equal to 5. 10 times 0.5 equals 5. Now let's go to the second one. The adjacent leg, now for this one, is equal to the hypotenuse, which is 20 times 0.866. So the adjacent leg is equal to 17.32, and the opposite leg is equal to the hypotenuse times the sine of 30, which is 0.5. So the opposite leg is equal to 10. I noticed it's exactly double. The hypotenuse is. It's double the first one, and the opposite leg is also double. Here it's 10, here it's 5, and the adjacent leg is also double. 17.32 here and 8.66 there. They're proportional. If this triangle here were 50% bigger, if the hypotenuse were 15, all the sides would also increase by 50%. And so on. If it's 20%, if it's 30%, it's because they're similar triangles, so they have proportional sizes. Now let's talk about the Pythagorean theorem, which establishes a fundamental relationship between the sides of a right triangle, stating that the sum of the squares of the legs is equal to the square of the hypotenuse, calling the hypotenuse here and the legs B and C. So, using this formula, what is the value of the hypotenuse? Using the Pythagorean theorem, the hypotenuse is equal to 3 squared plus 4 squared. So the hypotenuse squared is equal to 9 plus 16. The hypotenuse squared is equal to 25. Here it's an exponent. When you move it to the other side, it becomes a root. So it goes hypotenuse equals the square root of 25. The hypotenuse is equal to 5. Solved using the Pythagorean theorem. Let's go to another example. Using the Pythagorean theorem, let's do 20 squared, which is the hypotenuse, is equal plus the leg squared, which is equal to 16 squared, plus c squared, which is the other leg whose value we don't know. 20 squared is equal to 400. 16 squared is 256, plus the leg squared. Now here, since it's positive, we're going to move it to the other side as negative. So it'll be 400 minus 256 equals the leg squared. 400 minus 256 equals 144. 144 equals the leg squared. Since here it's an exponent, it goes to the other side as a root. It's always the inverse. So let's solve it here on this side. It'll be the square root of 144 equals the leg. The square root of 144 is 12. So the leg is 12. Here's the answer. Easy. Leave a comment if you had any trouble or if you thought it was easy to solve. In this video, I introduced trigonometry, the main trigonometric ratios, sine, cosine, and tangent, similar triangles, important trigonometric identities, as well as the concept of triangle similarity and the Pythagorean theorem. If you liked the video, subscribe to the channel and leave a comment. Thank you very much for watching, and see you in the next video.